This is problem 13, chapter 15 of Giancoli 6th edition. So this problem is very similar to the problem 12. If you understood problem 12, you should be able to do this one. Okay, it's again the same process involved, just different numbers and questions just slightly different. But the whole problem is very similar. Okay, so let's see what we have. Let's read it. So in the process of taking a gas, again we are thinking about ideal gas, from state A to state C along the curved path that is shown in the figure. So again here I have a plot of pressure versus volume. And somewhere here I have a point, a state A, that is taken to this state C. Okay, so this is A, this is C. All right, and in this process they give us the heat that leaves the system, so it's going to be negative, and the work that is done on the system. You see, to go from A to C we have to compress this this gas, so we are doing this work on the system to compress it. So what we have is this work to go from A to C is negative, okay? We are compressing this gas, is minus 55 joule is work done on the system. The Q that leaves the system as we go from A to C is minus 80 joules. Okay, so this is what they give us, and from here I can already find what is the delta U from A to C. Now the change in internal energy, because remember again we will keep using the delta U, the first law of thermodynamics. The delta U is Q minus work. All right, so if you do this here, you're going to find out that this change in internal energy is minus 25 joules. So let's keep all this here in this table. It may be very useful, it will be very useful later. What else do they give us? They say that the change in internal energy as I go in the path from A to B, so let me make this path here, as I go from A to B, so this is my point B, this change in internal energy, this U B, which is the final, minus UA, so I can also write this as delta U AB, is equal to minus 10 joules. Okay, so this is the final, this is the initial, this point is where I start, this is where we end. All right, so they also give us this change in internal energy. What else do they give us? They say that the pressure at A is related to the pressure point D. So let me put here this other process here because we will also expand from C to D. Okay, so this is the point D. So they say that, let me put this here, the pressure at point A, high up there, is 2 times the pressure at point D. All right, well, we also know of course that PA is equal to PB, so that process as I go from A to B is isobaric. Okay, I also know that this process as I go from C to D, expanding my gas, in as another isobaric process, so I also have that C is equal to PD. Okay, so let's keep also this information here. One last piece of information is the work to go from C to D to A. So there is this process as I go from C to D, expanding the gas, and then I go from I go from D to A without changing the volume. Okay, so in this process, as I go from C to D to A, the work is plus 38 joule. Okay, so this is all they give us, and now comes a sequence of questions. So let's start from question A. Question A is, what is UA minus UC. Okay, A is the final, C is the initial. So this means that we started at point C and went to point A. Okay, so what did they give us? Well, they didn't really give us, but what did we obtain up here? We obtained the change in internal energy as we went from A to C. Now they're asking just the opposite. What is the change in internal energy to do the inverse path, which is to go from C to A? Well, this is then just minus the delta UAC. Okay, so this is easy because we had already found delta UAC from the beginning, so we know that delta UCA is just plus 25 joules. Okay, so we are done with question A. Let's go for question B. Question B is, they are talking about this work that they gave us from C to D to A from this path. And based on that, the question now is, what is the heat? What is the heat for this path as we go from C to D to A? Okay, in this process we are expanding and we are adding heat to this gas, and we want to know what is the amount of heat that we add. I'm going to go for the first law. I'm going to use that delta U CdA is equal to QCdA minus work CdA. This work I have. What I want to find is the Q. Do I have the delta U CdA? Well, we do, because remember, the change in internal energy depends only on the final internal energy minus the initial, depends only on the final temperature minus the initial. So this delta U CdA is the same as delta U Ca. And delta U Ca we found here in question A. All right, so we do have that. This is this plus 25. The work CdA is plus 38. So we put all this together and we are going to find that this heat added is plus 63 joules. All right, very good. Let's go then to question C. Question C is, they are talking about the relationship between the pressures that we wrote here. And based on that, how much work is done by the gas. Okay, so how much work is done by the gas in the process A, B, C. So let me finish this process here. I go from A to B, I'm compressing, and then from B to C, I'm not changing the volume. Okay, so I'm not changing the volume, there is no work done. Okay, so the question C is, what is the work A, B, C? I know that this work is the work to go from A to B plus the work to go from B to C. From B to C, there is no work because there is no expansion, there is no compression, the volume does not change, isovolumetric, so this is 0. So all that I need to obtain is the work to go from A to B. The work to go from A to B is done at constant pressure, so it's PA, and as I go from A to B, I compress, this final value is B, and the initial is A. Okay, I can also write this equation in terms of D, the pressure in D, because they gave us the relationship between pressure in A and pressure in D. So I'm going to write this in terms of the pressure in D. So here I put 2.5, the pressure in D. The volume in B is equal to the volume at point C, and the volume in A is equal to the volume in D. Okay? So I see that this work in the path AB is equal to 2.5 the work in the path D to C. How useful is that? Do I have this work from D to C? Well, they didn't give me that explicitly, but they gave us the work from CdA, this blue equation here. What is this blue equation? Let me open this equation. What we have is that the work to go from C to D to A, which is a process involving an expansion, is the work to go from C to D plus the work to go from D to A. There is no work to go from D to A. This is just 0. So the work CDA, which is given to me, is equal to the work CD. So the work CDA is equal to the work CD, which is plus 38 joules. The work to go from C to D is expansion, that's why it's positive. But what I need now is this work here to go from D to C. Just the opposite, which is compression. So the work to go from D to C is minus 38. Okay, so what I have here is 2.5 minus 38 joules. So I multiply that and I will get what is this work AB. And this work AB is the same as the work ABC. Okay, so if you multiply that, you will see that we get minus 95 joules. All right, so we are done also with question C. Comes now question B. No, question D. Question D is what is the Q for the path A, B, C. All right, so let's write it up here. Question D is what is the work for this path A, B, C. A, B, C. So I compress from A to B. Then I just change the pressure at constant volume from B to C. Okay, how do I find this Q, A, B, C? I'm going to go for the first law. If I have the change in internal energy, ABC, and if I have the work, ABC, I'm done. All right, so this is the one that we want. Do I have the work ABC? Well, let's have a look. The work ABC we just found in this question C here, right? So I do have this work ABC. The work ABC is just minus 95 joule. Do I have the change in heat from ABC? Remember what we've been saying. The change in heat only depends on the final and the initial. So this delta U ABC is just the delta UAC. And the delta UAC I computed it in the beginning of this problem. Okay, so let me put all this together. What I have is this QABC is equal to delta UAC, which we know, plus the work ABC. Okay, so this QABC is the delta UAC, which is minus 25 joules, and the work ABC, which we just found in question C, so minus 95 joules. You solve this equation and you find that the heat is minus 120 joules. All right, very good. So we have just one more, which is question E. Okay, so in question E, they are referring to this value that they gave us, this UB minus UA. So let me write this here. So in question E, they are referring to this UB minus UA, which we know is delta UAB, which is minus 10 joule. Okay, so this is what they gave us. And based on that, they want to know what is QBC. Okay, so what is the heat as I go from B to C during this isovolumetric process. All right. Again, if I go to the equation for the change in internal energy, what I know is this: delta UBC is equal to QBC minus the work BC. The work BC, as we just pointed out here, is isovolumetric, so there is no work. This is just 0. So all that I need to do to obtain the heat to go from point B to point C is to find this change in internal energy. Well, they didn't give us that directly, but what did they give us? Well, we have this delta UAC. We obtained that. So let me also write this value here. This delta UAC is minus 25 joules. So minus 25 joules. So let's try to put all this together. How can this help me? Well, look, this delta U AC can be written as delta U AB, okay? So delta U AC can be written as AB plus BC, okay? So delta UAC is delta UAB plus delta UBC. Why I can do that? Well, this delta UAC is the final UC minus the initial UA. This one here, AB, is the final UB minus UA. This one here is the final UC minus UB. All right, so you see that this cancel and this is UC minus UA. So this is really true. I'm good. All right, so let's write this equation here again. What we have is this delta U AC is equal to delta U AB plus delta U BC. Delta U AB they gave us. It's here. This delta U AB is minus 10 joules. Delta UAC we computed in the beginning of the problem. This is minus 25 joules. Okay, so from here, from this equation, we find delta UBC. Delta UBC is therefore minus 15 joules. Okay, this is what I need to find this Q. So this Q is minus 15 joules. And this is the end of the problem. Again, many steps involved problem, but if you understood 12, you should be better off with this problem 13.